Hi everyone, today we're going to be looking at more key terminology of sinusoidal functions. Okay, so what is a period and what is the amplitude of this particular function? Okay, so the first thing that we're going to do is we're going to go ahead and draw in the axis of curve. And so if I choose this as my starting point and that as my ending point, this is my AOC. So that's at y equals 2. Okay, so then I need to figure out the amplitude. So from the axis of curve to either the maximum or from the axis of curve to the minimum, that is, let's see, 1, 2, 3 units. So the period equals the amplitude equals 3 units. I think I said the right thing, but I wrote the wrong thing. So the amplitude equals 3 units. The period of the function is between one starting point and one finishing point. This is a cycle. So this length here is a period. Or I could choose this as my starting point and count this as a cycle. So as long as you're consistent, so if I chose this kind of 0 position, so my period is 2. If I look here between -3 and -1 is also 2. Or I could have looked between peak and peak, that's also 2. So the period of the function is 2 units. Okay, next we're going to determine which function or functions are periodic. So does it have a repeating pattern? So the first one, yes. The second one, yes. The third one, the length of the min and the max is not consistent, so this one is not periodic. All right, let's look at a few more examples. So same thing with this A, so it doesn't have a consistent max and min, so this is not periodic. This one is periodic, kind of reminds me of a heartbeat. I would say that this one is, and then D is not periodic. All right, let's look at a couple examples here. Throwing a tennis ball against the wall with a steady pace, hitting the same spot each time. So because of these key components, the same pace, same spot, yes, this would be periodic. All right, what about the path of a tennis ball in a tennis match? So if you think about a tennis match, it doesn't go to the same spot every single time, right? It's a little less consistent. So no, this is not a periodic function. The path of a roller coaster at an amusement park. If you think of it in terms of a single round, no, it's not the same loop-de-loop the whole way through. But if you think of it as one time through the roller coaster is as one kind of cycle, and then the next time you go is the second cycle, then that, if you're comparing those particular cycles of the entire roller coaster, then yes, it would be periodic. So I guess you could kind of argue both ways for this example. All right, let's go ahead and skip on ahead here. The next one, pushing a child on a swing. So, I mean, at the start, once you get started, no, because it doesn't have the same amplitude. But once you get going, it's pretty steady. So we'll say at the start, no. In the middle, once the swing is going steadily, yes. All right, the next one, a dog's tail wagging when it sees you. Yes, my dog gets very happy and the tail is wagging pretty consistently. All right, so we're going to look at some properties of periodic functions here. So just to redefine a few things here. So a cycle is the smallest complete repeating pattern of the graph. So the smallest complete repeating pattern of the graph. Okay, so just as I was demonstrating earlier, so we could pick a max and a max. So you could call that one cycle. And then from this max to this max, that would be another cycle. Okay, next, the period. The period is the length of one cycle. So in this case, so let's say we're looking at the minimums this time. So that is the length of one cycle, the period, or we can look from here to here. Okay, so that's 1, 2, 3 units. Okay, next is the axis of curve. And this is the horizontal line that's halfway between the max and halfway between the min. All right, so there is a formula for calculating the axis of curve. So the AOC is equal to the max plus the min divided by 2. Okay, next definition is amplitude. So the amplitude is the magnitude of the vertical distance from the AOC to either the max or the min. So it's the magnitude of the vertical distance from the AOC to either the max or the min. All right, so again, if we sketch in our AOC, so amplitude is this distance here. Okay, oh, axis of curve on the previous one, I forgot to sketch that in. So in this case, the AOC is the equation y equals 0. So because it's a horizontal line, it's always in the form of y equals 0. The amplitude also has a formula. It's very similar to the AOC, except instead of adding, we're subtracting. So the amplitude is equal to max minus min divided by 2. So in this particular case, if we look at 1 minus -1 divided by 2, we get 2 divided by 2, which is 1. And that's what we can see right from the graph as well. All right, so let's look at some key features of this function. So determine the period, the axis of curve, the amplitude for each of the following functions. Okay, so the period here, so again, I can choose any starting point. I could choose any of the mins and just count boxes, or I can subtract 450 from 90 if I use this as my example here, or I could pick 270 and -90 and I could count there. So the period is 360 degrees. The axis of the curve, so halfway between the max and the min, is at 2. And make sure it's an equation. Y equals 2 is a horizontal line, so it should be in the form of y equals some number. The amplitude, I can easily see that it is 1. So amplitude equals 1. Or I can use my calculation, right? So 3 minus 1 over 2 equals 2 over 2, which is 1. And then also I could have done the same thing with the AOC and made a calculation. So for the AOC, I could have calculated 3 plus 1 over 2, which is 4 over 2, which is 2. So y equals 2. So either way, looking directly at the graph or by the calculation. All right, the next one. So this time, same idea. I'm going to pick my maximums up here between 450 and 90. So that looks like the same period as before, so 360. The axis of curve this time is here, so that's at 1.5. So y equals 1.5. So again, if you want to calculate the AOC, y is equal to 4.5 is my max, and my min is at negative 1.5, so plus negative 1.5, and then divided by 2. So we would get 3 over 2, or if you want to work with decimals, 1.5. For the amplitude, again, you can either count boxes or 4.5 minus 1.5 over 2, which is, minus negative, double negative here. Oops, let's see if I can fix that. Over 2, so then we're going to get 6 over 2, which is equal to 3. And again, I could count boxes as well. So this is a half, a whole, and a half, which is 3. All right, next we're going to see if we can work backwards and make a sketch here. So if I give you the period, the amplitude, and the equation of the axis of curve, and the number of cycles, let's see if we can sketch this. Okay, so the first thing I'm going to do is I'm going to go ahead and put in a little bit of a scale down here. I'm sure your drawing is going to be much more beautiful than mine. Okay, so my axis of curve is at 4. So 1, 2, 3, 4. So here's where my AOC is. Okay, the amplitude is 2, the period is 3. So that means every 3, so if I start here, every 3 is a complete cycle. So this is going to be really tight actually. So in between 1 and 3, which is 1.5, we're going to have a turning point. And then my amplitude is 2. So I need to count in between those. I need to go up 2 boxes. In between the second and the third dot, I need to go down 2 boxes. So here is one really tight cycle. Okay, but I need to make 3 cycles over here. So my next cycle, so again, every 3, halfway in between is a turning point. So I'm going to go up here, down here, 2 boxes. There's my second cycle. And again, every 3, halfway between is my turning point. There's my max, there's my min. My amplitude is 2. And there's my third cycle. All right, we'll look at one last one here. So we have the period, the amplitude, the AOC, and the number of cycles. Okay, so same thing. I'm going to start with just a little bit of a scale to help me out. Okay, so my AOC this time is at 1. Okay, my period is 2. So this one's going to be even tighter than the last one. Okay, so halfway between is my turning point. My amplitude is 4, so 1, 2, 3, 4. Oh, this is going to be a really tall one. Okay, so there's 1, and I need 2 cycles. Okay, so there's my second one, my turning point, amplitude of 4. So I'm basically just continuing the pattern, right? And that's it, 2 cycles. Okay, that's it for today's lesson.